Alright, so maybe completing the square doesn't seem like the most convenient way to solve a quadratic equation. Maybe you'd like to just work through completing the square once and for all and write down a formula showing what you're always going to get. Maybe you noticed a certain sameness to the sorts of steps that we took to solve a quadratic equation by completing the square. Fair enough. Let's write down a quadratic equation. Ax squared plus bx plus c equals 0. What would we do in order to solve this by completing the square? We would subtract c from both sides, and we would have ax squared plus bx equals negative c. Then what would we do? Right, we would divide both sides by a, and that would give us x squared plus b over a x equals negative c over a. So far, so good. This next step is going to be kind of weird with all these variables here, but bear with me. I'll want x squared plus b over a x plus something equals negative c over a plus that same thing. Well, watch me give myself a little bit of extra space in this box, because I'll have an x squared term up here. And now I need to split my b over a times x in half. I'll have b over 2a times x here, b over 2a times x here. This box then will be x by x. This box will be x by b over 2a, as will this one. This box will be b squared over 4a squared. All right, fraction addition break. All right, I have negative c over a plus b squared over 4a squared. My LCD is, of course, 4a squared. Negative c over a. What do I need to multiply a by to get 4a squared? I need to multiply it by 4a. So this addition problem is the same as negative 4ac over 4a squared plus b squared over 4a squared. That'll be negative 4ac plus b squared over 4a squared. And I would rather write that as b squared minus 4ac. We now return to our regularly scheduled completing the square, having successfully added these fractions. Right, over here I'll have x plus b over 2a all squared is equal to b squared minus 4ac over 4a squared. Okay, time to use the square root property. I get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared. Simplifying this square root, now this is a perfect square, right? The square root of a squared, that's going to be just a. Actually, it's the absolute value of a, but I've also got this plus or minus, so I'm going to leave out the absolute value. I've got x plus b over 2a equals plus or minus root b squared minus 4ac over 2a. That's nice, right? Common denominator here. Subtract b over 2a from both sides. I get x equals negative b plus or minus the square root b squared minus 4ac all over 2a. That was a mouthful, right? Do I expect you to be able to go through this derivation on your own? No, absolutely not. What we've just derived is called the quadratic formula. And we are going to, in general, prefer using the quadratic formula over, for example, solving by completing the square. But notice what we've done here. We see why all of the little weirdnesses that turn up in the quadratic formula do. We've seen why this turns out to be a negative b, why we get b squared minus 4ac all inside one square root, why this part is plus or minus and this part is not. Seeing the derivation once is helpful for us because it helps us remember how the pieces go together here. From here on in, though, we can refer to this formula in our notes when we want to use it to solve a quadratic equation.